Hey everyone, this is Juan Sacco from Expert Pack. Um, on this video, I'm gonna show you how to develop an exploit in Kali Linux. Is this at the time I'm recording this video is the latest version of it, and well, I'm gonna use it on a virtual machine. I have it here on a Ubuntu system, and for this purpose, yes, I'm gonna choose this exploit JAD, Java Decompiler 1.5 local buffer stack based overflow because it's pretty straightforward, really easy to do. Yeah, as I said here on this exploit in the comment, the Python code, it works for Kali 2017 release. And yeah, so if you install Kali, you should already have installed this binary, call it JAD. These are Java decompiler, and well, this program is vulnerable to a stack-based buffer overflow vulnerability. So I'm gonna use it because you don't have to install the program or get the program anywhere. Just get Kali, and then you are ready to go. So I'm using a Ubuntu system, and on this one I have running a virtual machine with Kali, the one you see here. So go full screen. So yeah, oh well, first let me copy the exploit itself. So boom, copy, yeah, let's open a terminal. I'm gonna use B. You can use the editor you like it most. I'm here. So let's create one JAD. So I'm creating a folder, call it JAD, then you go into the folder. I'm gonna use P and create exploit.p. Yeah. So I'm gonna do it manually. It's easier if you use a framework like exploit pack, where you can also use Metasploit for this. And well, I'm gonna save it. Yeah, and then I'm gonna show you JAD. Type it like here, -b. Then you have all the commands. The version of it is 1.5.8. And yeah, so if I did the exploit again, then you will see this is a pretty easy one. So basically, you have junk um, equals to 41. It's a capital letter A, and then I fill it with 8,150 A's. So that will go into the buffer. Then I have the knobs. Yeah, and the knobs choose to fill it. I'm gonna use 24 knobs. Yeah, then I have a shellcode. This shellcode is just a call to system, and it's gonna pass as an argument being sh. Yeah. Then later I'm using this rob call. So basically I'm returning directly into a shop call. That is basically I'm using call ASP. I'm getting this one directly from the binary itself, and then choose constructing the buffer here, buffer, and then it will chunk this one, the values by 1,150 ESP. Yeah, that that's my return value. Yeah, and then I have knobs. Yeah, if you hear that, that's my dog that is walking near mine. Yeah, uh, she's pretty pissed off because she wanna go out. Yeah, maybe after making this video, I will take her out. Okay, then continue. Shellcode. I have the shellcode here. I'm gonna put it here, so it would be chunk ESP knobs. So I'm gonna land into the knobs, and then boom, execute the knob until I reach my shellcode. Yeah, that's how I craft the buffer. Then I have a try catch exception, and then just print some message on the screen, blah blah blah, stack buffer overflow, please wait, running. Then I call some process call, and then I pass JAT, and then as an argument the buffer. Yeah, then if I get an exception or it's error as E, then if it's different, then because I don't, if it's different, then it's because I don't have JAT installed because I cannot find it. Or otherwise, then choose print error or execute an exploit. If it's something else, then rise. Okay, so what do I like to use? The tools I would like to use in Linux. I like to use GDB. Yeah, you can use the debugger you like it most. I don't use only GDB. I use GDB with Peda. So let me show you what is Peda. So Peda, GDB. Oops, yes, I was doing a pen test, so I was using barb, so I have to take up the proxy. Boom, yeah, like that. That will do. Peda, yeah, this is the one. So Python Exploit Development Assistant for GDB, yes. So how do you get it? Just copy this like that, and then you go to terminal, paste it, yeah, paste, not on GDB, but paste it on terminal, and then you will just clone the repo, yeah, this one, the one that we are sitting on, then echo. So basically it's gonna get the source of peda.p and then put it on GDB init, that is the profile for GDB, and then choose echo. Yeah, you got it, echo done. Yeah. So it's pretty useful because it's let's first, so I can show you file chat. Yeah, yeah. So I got it running. So now if I do peda help, then I have all the commands for peda that I can use. One of the first one that you have to do is to check sec. Yeah, so with check sec, it's gonna check the security, that it checks for various security options for this binary that I have loaded on my debugger. Yes, I'm drinking coffee. Um, and then what else? Well, this one I don't have a canary. I don't have 45. I do have an X. Yeah, so it's enabled. And I have P. Yeah, and then I have railroad also disabled. So um, pretty straightforward. I can run this exploit, so that's why I choose this binary, because not only because it is installed in your Kali. Yeah, if you are watching this video during the time that the latest version of Kali includes JAR without the fix for it, well, then you can choose to do it. And that's what I'm doing it. Not only, well, as I say, not only that, because also this binary itself has almost no protections. Yeah, so it wasn't compiled with protections, so no canary, not fortify, nothing. Yeah. Uh, well, um, after you have that, yeah, you can choose start doing breakpoints, break main. But before doing that, after I explain, oh, yeah. After I explain this, so what other tool you can use that I like is object dump. First, let's check where is that. Yes, object dump -d for disassembly. That chat. Yeah. So this is not really useful if we want to use, if we wanna choose do some rob calls or create gadgets or choose find calls. So there is something we can do. We do gdb jad, yeah, we go to beta help, then we can use jump call, and or we can use rob gadget, rob search. I think we have to run it. So yeah. So what I'm gonna do is to choose run this program. Like that. So basically, I just running the command inside GDB. I'm pasting as argument Python, yeah, in line. So basically, it's Python, and the argument for Python is gonna be print a by 9000. Yeah. So there we have the overflow. We can see it here. So now that we have it running, we can do some call, and then in memory we can check all these addresses that we can use. Yeah. So let's press quit. So because there are way too many. So now we can do rope gadget, and then it will take some time, but then we have it there. Then we have all the gadgets. For instance, pop red, 4 pop red, pop red. Yeah, yeah. That's how it goes. But there is another one, and maybe you already know about it. Rope gadget. Tapping it wrong, but anyway, I think Google fix it for me. So what you can do, yes, door gadget. This is the one. Door gadget tool. So yeah, see, so you install it like this. You sudo pip install capstone because it's needed, and then you can choose run rope gadget, and then if you run rope gadget into the binary as it says here, then you can choose get all the gadgets. It will find the gadget for you directly in the binary. Yeah. So if you need to, I don't know, typical gadget is like a constructing string copy and then calling system, and then you can do it directly with that in a few seconds. I mean, it's really easy if you use drop gadget. Otherwise, you can go old school and choose do it yourself with a tool like I show you, object dump -d. We say like this, right? Yeah. So and here you can start constructing the gadget yourself. Yeah. Let's go back to GB. Let's run again. Yeah, so if you press the cursor up or down, then you can choose go to your history, through your history. Yeah, yeah. Well. So what happened here? So we pass the argument. So it's 9008 into the binary, and the binary just go overflowed. You know, and because the stack got overflowed in the stack, it saves the stack pointer, the back pointer directly that is gonna be passed directly to ESP. Yeah, so that's why if we check the value for ESP like this, so X for dump, the times, and then X if you wanna do it in exa. So and then we pass the in this case it will be ESP like that. Yeah, or if we wanna do it as strings, yeah, and we have it like that. So different types of printing it. So it's not gonna just put the whole amount of phase. It's gonna see, okay, repeat it 200 times, repeat 200 times, 1 time. There how it goes. Yeah, so that's how it works. And if we do info registers, then we can see the value of the registers again, or ER is the same, it's a shortcut. Okay, another command that would be really handy for you to know is backtrace. So if you type backtrace, then it will show you what happened with this program. So it failed execution because it was trying to access 41, 41, 41, 41. That means that we overflow the value of the instruction pointer. So the return address pop up the value from the stack and then pass the value directly into the instruction pointer, and it wasn't a real memory address, so it failed, so it couldn't went there. So that's when you produce the segmentation fault. Yeah, that's the failure of the segment. Yeah, that's how it works. Okay, now that we know how it works, let's open a new one. Yeah, like this. Oh, by the way, this is pretty useful. So we have Peda. This is not about Peda. This tutorial is not about Peda, but Peda is a really handy tool to use. It will save everything there. Well, now not because I'm actually using it, but you will have everything there on your from the session that you are running. Yeah. One more sip of the coffee. Yeah. Okay. So now we are doing this. How do we found? Because you say, yeah, okay, you overflowed it with 9,000. Yeah, those are my batteries for my drone. That is ready. So anyway, so 800 and 150, 8,150, sorry, A's. So how did I found this offset for overriding the instruction pointer? Well, what you can do like this, like manually. 8,000, no. 9,000, yes. Or, and I did not want to go right, just adding more, adding less, like 8,200. And then, oh no, yeah, I almost got it. Okay, well, we know that is 150, yeah. So now you see that if we add the CBA, so 41, 42, 43, 41, 44, yeah. I am adding the CBA because it's Little Indian, so it will pass the values in reverse. So A, B, C, D. So A is equals A 41, B 42, C 43, D 44. But there is a better way because, for instance, if you ask me, hey, but on which offset are you representing the value of EBX or EBP, the back pointer? Where? Well, there is a better way, and we can do Peda, directly create pattern, or pattern create. Yeah, I'm getting confused because they use different words in Mona and GDB. I actually Mona, choose Mona from Corlan. Mona to be later on when I do some sort of same video but for Windows. I will show you how to use Mona. That is basically yeah, that's basically the same but for Windows. Construct gadgets. I know it does a little bit more than Peda, but yeah, it's sort of the same niche. Yeah. Okay. Anyway, pattern create, and as the command say, you have to specify the size. So let's say 9,000, and then we have the pattern, and then we can choose. We can dump it into a file, and then choose to it more clean, but just for the sake of just showing you how it works, and I will use the same example, but now instead of printing this, boom, 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 so instead of printing A, I'm choose dump the pattern. So like this, yeah, tuk tuk tuk, and then like that, copy, and then paste, and then there we have it. Yeah. So now instead of sending as an argument and overflowing this stack on JAD with A's, what I'm doing is sending in a pattern. Yeah. Okay, but now how do I found the pattern? So do Peda help, and if we go back here, then we have pattern search, and then what it's gonna do is search cyclic pattern in registers and memory. So that's what we want. Pattern search, enter, and then as you can see, we have ape, yeah, instruction pointer, extended instruction pointer is found at offset 8,150. Then we have the back pointer, ECX, EBX, yeah. So that's what we need. Because on this one, this is a really easy stack buffer overflow. We are already overflowing the stack and taking control of the instruction pointer. Then we can choose to do this, yeah. Register and point to pattern buffer flow, buffer found here on the heap, and yeah, we are done. So that's how we found this with a pattern. Yeah. So let's change it for 44, 44, 44, 44, like that, and then we have control of it. So that's how we got this offset. So then we have the knobs that are the no operation instruction point for no operation for it's still for no operation. Let me show you what I mean. Knobs 90 assembly. And there we have it here. Boom. So a knob is commonly used for timing purpose, for memory alignment, to prevent hazard, require branch delay slot, to render void existing instructions to such jump, blah 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 blah. So basically, what is an operation? So basically, if you fulfill your stack with knobs instead of a shellcode, what it's gonna do is to go there, get it, execute it, and then it will continue the execution until you reach your shellcode. Yeah. So basically, it's always good to have a knob, so because you can land there instead of just trying to land in the alignment of your shellcode. So you can use NOP to align your shellcode to the stack, or you can use NOP as a test instead of a shellcode. Yeah. So if you are developing your own shellcode and you are not sure if it's working or not, or if it's properly aligned or not, you can choose to use NOPs and try to see if you can actually execute it or not. Yeah. So how do we got this one? I already showed you how do we got the calls. Yeah. So what if you jump call? And then we have to look for because I believe we can pass another jump call ESP. It's like that. I think it's like that. Yeah, well, there we have one. It's the same one or not? Yeah, well, it's exactly the same one. So you see it's 80 E2 E18. So that is this one. As you can see, as I said before, it's the linear. Well, on this exploit I just put it directly like that, but you can use struct on the Python library, Python struct, and then you can the library for you will yeah, this is the library struct. You can choose do it in the correct way, and then choose paste the memory address in the, and then use L to choose actually make it reverse when you pass it. Okay, then we have the buffer. Craft the buffer, and then yeah, I think guys we are done. So should we try it? Yes, let's try it. So how can we try it in GDB? Blah, 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 because this one is actually subprocess call. Blah, blah, blah. So what we can do? Yeah, let's try this. Comment this part. Yep, like that. Oh, missing one. Okay, so let's do like that, and then you know what? We can choose print buffer. So now if we do like that, well, we can see the result, right? So it's 8,158. Then we have the NOPs that you can see there, and then the shellcode, yeah, plus the return address. That is this. Yep. Okay. So chunk ESP NOPs shellcode, yeah. Yep. Okay. Why did I did that? So so we can actually just call the exploit itself from here. So run Python exploit dot p like that, yeah, and then we have it, and as you can see, we have overflowed the exploit itself, and then we got the root, yeah, and then because we were running it inside the GDB just stop logging, so stop at the process itself, but we got the shell. So now that's how we can run it inside. Let's do it again. Python. Oh, sorry. Run Python exploit.p. Boom. We got the shell. Yeah. So if we wanna do it outside, yes, I saw that. Like that. Yay! It's working. It's calling, and then we have it here. And it's working. Guys, thank you so much for watching this video. And what can you tell? What can I tell you about this series? So this is a really easy stack buffer based overflow. On the following videos, I will show you how to bypass some protections. Like we check it here. Let's kill this one. Boom. Yeah, like that. So. So what we would like to try, well, we will try to bypass canaries, fortify, no execution, and for that we need to, we need to understand how those protections work. So in the following video, I will show you how to do it, how they work, and how to bypass them. Thank you guys, and that's my dog again, and see you on the next video. Bye.